So today we start conditional probability. Conditional probability is calculated when additional information is known that will affect the probability of an outcome. Conditional probabilities deal with the change that comes from factoring in prior information. The probability of one event given that another event has occurred is a conditional probability. The probability of one event. So basically what happens is our sample size is reduced, right? So instead of having probability of your sample, or instead of going the number of ways A intersection B can occur over the number in our sample space, we no longer have that. We have it over the number of ways B can occur. So in effect, it's a reduced sample space.
So, Miss Kaczynski,
Yeah?
for the notation, is it supposed to be number like NB or P of B?
They're both will give you the same answer. Yeah. Because this one is just number of A intersection B divided by the number in our sample space, number in B divided by the sample space. So in effect, it's just a reduced sample space. So we have to factor in this additional information, and how does that change things? Let's look at an example. What is the probability of rolling a sum greater than 7 with 2 dice if it is known that the first die rolled is a 3? Okay, let's just do a partial die chart. We don't need to kill ourselves. Or we don't have to do it every item in here. So given the first die is a 3, we're going to focus now there. See, this is now our reduced sample space. So we'll say that these sums are 4, 5, 6, 7, 8, and 9. So given that the first die rolled is a 3, what's the probability of rolling a sum greater than 7? So let's say A is sum greater than 7. And B is first probability roll of the first die being a 3. So the probability of A intersection B divided by the probability B has occurred is equal to, well, sum greater than 7. There's 2 ways that can occur, so that's 2 over 36, right? All over 6 over 36. So this is going to work out to be 1 over 3. So the probability of A given B equals the probability of the intersection, which is 2 out of 36, divided by the probability of B, which is 6 out of 36, and that's going to work out to be 1 over 3. So given the first die rolled is a 3, our reduced sample space, and then the intersection of the 2 events. If a family is chosen at random from the set of all families with exactly 2 children, find the probability that, well, let's see, boy, girl, boy, girl, boy, girl. Okay. So what we want is, what's the probability a family has 2 boys if it is known? So this is our given, right? Given that one child is a boy, so probability of 2 boys given one child is a boy is the probability of 2 boys intersection at least one boy, or no, just if it is known that This should really say at least one child is a boy. At least one child is a boy. That at least one child should go in there, okay? All over the probability of at least one boy. Okay, so let's look at this. This is part A. Alright, at least one child is a boy occurs here, here, and here. There's 3 ways that can occur. So at least one child, the probability of that is 3 out of 4. And the probability of 2 boys is 1 out of 4. And that equals 1/3. Makes sense? Probability of 2 boys, if we give in first child is a boy. So now we want to do the probability of 2 boys intersection first a boy all over the probability first a boy. Okay, so if you notice, probability 2 boys intersection, here's the first is a boy. This is our reduced sample space. Right? So the probability of 2 boys intersection, what they have in common is this, is 1 over 4 all over. The first is a boy is 2 over 4, and that is 1/2. The probability of the first is a boy, there's 2 outcomes there, which is 2 over 4. See, if you can see it as a reduced sample space, conditional probability is really easy.
So when you do 2 boys union the first is a boy, you don't consider that as part of the reduced sample? Because the reduced sample, there's only 2 outcomes.
Yeah. So the first is a boy there, the first is a boy there.
So that would be
2. And then the intersection of 2 boys and the first is a boy is just 1 over 4. Yeah, you can do it like that, or 1/4 divided by 2/4, depending on which formula you want to use. You want to use this one. I'm using this one. Right?
No, but what I'm asking, so right now, for 2 boys intersect the first boy, using the way you're doing it, you're reducing the sample size, so there's a total of 2 outcomes. Or
First, total of 2 outcomes for the first is a boy. 1, 2. So the probability of first being a boy is 2 out of 4.
okay, yeah. Okay, I get it now.
Reduced sample size or reduced probability on the denominator. Maybe that's what's throwing you. Yeah, okay. When 2 friends, Brian and Hugh, play ping pong, Hugh wins 60% of the time and Brian 40% of the time. However, Hugh will win 2 in a row 50% of the time. It is given that Hugh has won the first game. What is the probability he wins the second? Okay, let's just maybe set up. We have 2 games happening. Okay. All right. When they play ping pong, Hugh wins 60% of the time, and then Brian wins 40% of the time. However, Hugh will win 2 in a row 50% of the time. So what they're saying is the probability Hugh wins first, intersection Hugh wins second, is equal to 0.50. So what they want us to do is, if it is given that Hugh won the first game, what's his probability? We know what his probability is when he wins the first and the second, but we want to know the probability. Given he wins the first, what's the probability he wins the second? So we want probability Hugh wins second given Hugh wins first is equal to the probability Hugh second intersection Hugh first all over the probability of Hugh first. Well, we know the intersection, and we know the probability he wins first, so that's 5 over 6. So 0.6 times 5 over 6, that times that will give us 0.50, right? This is a conditional probability. Given he won the first, what's the probability he won the second? Is that my cell phone? Okay. Oh, I thought it was just one page, but it's two. A recent national survey indicated that 15% of the population is left-handed. 10% excel at math. Is that all it is? In our school, I would think it's more. Probability of math, sorry? Yeah, thank you. 15%, 10%. The intersection left-handed and excel. So, given that an individual is left-handed, what is the probability of excelling at math given left-handed equals the probability of excelling at math intersection left-handed all over the probability left-handed. So there's the intersection. It's 1 over 5. In a factory, 45% of the output is from machine A. That means the remaining is from machine B. Alright, so it's either defective or good. The product is either defective or good. So from machine A, 2% is defective. That means 98% is good. And from machine B, 0.015 is defective. And that means 0.985 is good. So, they want to know what's the probability that given a certain item is defective, it was produced on machine B. Okay, probability given it's defective, it came from machine B. Okay, we can have a defective product here, right? And then the intersection will be here, right? That's our intersection between these two. So the probability of B intersection D is 0.55 times 0.015, and the probability it's defective we get from these two branches. Uh-oh. No, I picked up the wrong one. It should be 0.015. So we get, this should, so 0, that's right, and that's right. So this works out to be 11 over 23. Okay. Can I answer any questions? Yeah.
For equations like these, do you want us to leave it in fraction form, or it doesn't?
Fraction's best. It's more accurate. The probability pat to Eastern is that. The probability she goes to another university, let's just record. If Pat goes to Eastern, the probability Giles will follow, they're an item, right? So the probability Giles to Eastern given Pat to Eastern is equal to 3/4. What is the probability both of them go to East? So what's the probability Pat to Eastern intersection Giles to Eastern? That's what they want us to calculate. So we plug it in the formula. Probability Giles to Eastern given Pat to Eastern equals probability Pat to Eastern intersection Giles to Eastern all over probability of Pat to Eastern. So this is 3/4 equals the intersection. That's what we're calculating. Probability she goes to Eastern is 1/5. So probability of Pat to Eastern intersection Giles to Eastern equals 3/20. Cross multiply. What can I say? Yeah, just subbing in what we know.